Before we get started with today's video, I just want to give a shout out to two people on YouTube. The first of which is Engineering Scale Models. So Engineering Scale Models is a ex-engineer who used to work on power supplies and things like that, but now he works on consoles such as Xbox Ones and Nintendo Switches. So we're trying to get him to 1,000 subscribers by the end of January, so if you could head over to his channel and subscribe, show him some love, that would be absolutely fantastic. And the next person that I want to give a shout out to is Micro Mag Repair. So Micro Mag Repair is trying very hard to build a channel. And the next person I want to give a shout out to is Micro Mag Repair. Micro Mag Repair is trying very hard to build a channel, and he currently has 101 subscribers. So if we could help him to build his channel, as you can see here, he has quite a lot of Nintendo Switch and PS4 stuff and other repair stuff. But if we could help him build his channel and try and get him to 1,000 subscribers as soon as possible, that would be absolutely fantastic. As you can see, he uploads an awful lot of videos. So if you have any issues with things like Nintendo Switches and PlayStation 4s, if you want to learn how to solder and things like that, be sure to check out his channel and subscribe, show him some love and help him to grow on YouTube. But without further ado, let's get into today's video. Hello ladies and gents, welcome to another repair video. Today we're going to be working on this Xbox One X, which has been sent in. This particular console has been sent in because it has no display. So if we take a look at the ticket here, we'll see that number one, Console Repair London is running out of receipts, hence the red lines. And number two is Xbox One X, no video output. So this console, like I said, doesn't display anything on the screen. And what we're going to do is, I'm going to do what I always do first of all, and I'm just going to pop it onto the computer through a HDMI capture card and just see if we can pick up what's going on first of all, and then we'll see if we can fix it. So let's pop in a HDMI lead here. And that felt nice and tight going in there, so the HDMI port should be fine. Okay, and let's turn it on. And I'm going to load up my camera app. And by the looks of it, we get absolutely nothing. So no display output whatsoever. Let's just give the HDMI port a bit of a wiggle. And nothing. So nothing showing up whatsoever. So what I will do, just to double check, I will check it on the monitor without the capture card just to make 100% sure. Okay, so I've got it plugged into the monitor now. Let's just wait for it to flick over. And we get absolutely nothing on video output whatsoever. Okay, so just to show you that is working, there we go. So I'm going to get this apart and then I'll see if I can figure out what's going on with it. So first of all, let's just take a quick look at the HDMI port. And that does indeed look absolutely fine inside there. So most likely not going to be anything to do with HDMI. Okay, so just about ready to take the motherboard out now. One thing I'm noticing is it's not extremely dusty, but it is kind of dusty. And one thing that I've noticed that when we have display issues on an Xbox One S and X in particular is that what you'll tend to find is that it's usually down to either one of two things. The first of which being because people keep unplugging and plugging in the HDMI cable, and when they plug it in, they're plugging it in blind. So for example, the console is facing this way and they're reaching over and they're trying to find the port, and they end up putting it in on an angle and shorting out some pins. The second reason that I've found is usually down to overheating. So 9 times out of 10, what will happen is the console will overheat because of dust, because of the thermal paste not doing its job properly. And what you'll tend to find is that the HDMI encoder will burn out because of heat. Or at least that's my theory. I'm not 100% on that, but that's the only reasonable explanation I've been able to come up with when the console isn't constantly being unplugged and plugged back in. Now, I don't know the situation with this exact console because I don't get to talk to the customer direct, but like I said, the HDMI port feels nice and solid, so I'm going to say that it's probably not been unplugged and plugged in too many times, and it's probably down to some sort of a thermal issue, because no matter what component it is, whether it be a capacitor, a resistor, a coil, or an IC, or anything else, every component has got a maximum operating temperature. And once it reaches that temperature, you'll start to experience problems such as glitching on the screen, no display at all, intermittent display, flickering, that sort of stuff. And the IC will eventually burn out, and that could have been what's happened here, because I can't see any reason so far why we're getting no display on the console. Of course, I could be wrong, it could be a completely unrelated reason, but that's one of the viable reasons that I've come up with for the HDMI encoder dying on these machines and on the PS4 as well. Because sometimes there's just no explanation for it. I've actually known these consoles to be in situ for several years, a couple of years, and then eventually the HDMI encoders died for no reason whatsoever, and one day it works and the next day it doesn't, and there's just no explanation for it. So I mean, they are definitely a weak point on these consoles, or on consoles in general. The Xbox One X, the Xbox One S, the PS4, all the PS4s, the Nintendo Switch as well with the P13 USB chip. They all have a weak point, and the weak point on these, what I tend to find, is the HDMI encoder, and it can cause all sorts of problems. It can cause the console to not turn on. So you can get various different symptoms, and as you can see, that thermal paste is definitely not going to be doing its job, and I can't see, upon first glance, any other reason why we could be experiencing any kind of issues with the display. So what we'll do, we'll go under the microscope now, and we'll do a few tests. I'll give this all a good clean before I put it back together, but we'll do a few tests. We'll check the pins on the port, check the Emi filters and the capacitors around the chip and things, all the usual tests, and if they all pass, then we'll just change the HDMI encoder anyway. Okay, so taking a look at the HDMI circuit, then the first thing we come to is obviously the HDMI port itself. Now, we've already checked the inside of the port where the HDMI cable meets the port itself, and that appears to be fine, but I am going to check the back legs and make sure that none of them have come loose over time, and make sure that it's not going to cause any issues. It's not usually the case, but it's a simple thing to check, so I always check it anyway. So I'll just give them all a nudge test by nudging them with a pair of tweezers, make sure that none of them are loose, and that one of them could be causing a problem. I have come across it once where I've had loose pins, even from factory, but it's just one of them things. I always check it anyway, and all of those pins, all 19 pins, seem absolutely fine. So the next thing we're going to do is we're going to work our way down the circuit. If we look on the left hand side, pins 19 through 14, we do have some components here. So we have some resistors, we have this IC here, and this IC I believe is some sort of power management IC. There's no information on this IC at all, and you can buy the Xbox One S equivalent to this, but you can't buy this chip. So if this fails, the only way to get it is to take it from another board, a donor board, and reboard it. So that's obviously an advanced repair right there. There's no real way to test this apart from checking the capacitors around it and hoping that it's good. But I will check these capacitors really quickly and make sure that we don't have any shorts to ground. Because if we do, then it's straight away it's a no fix, because I don't have any donor boards that I can take that chip from. So let's pop the multimeter into continuity mode then. Continuity mode is the mode that beeps when we complete the circuit, and I'm going to put one probe on ground. In this case I'm going to be using the HDMI port, and I'm just going to test these capacitors around the chip itself for a short. So if we look on this side here will be ground. So we get a beep. And this side we shouldn't get no beep. And we don't. Same with these. No beep. And no beep. So that appears to be fine. It does appear as though that's fine. So if we carry on down the circuit, then we take a look at pins 13 through 1. So 1 being on the right hand side and 13 being just here. Then we can see that we've got a couple of components here. Now these components here are 8 Emi filters, and these filter out electromagnetic interference on the data lines. So there's no point really testing these, because the console would work if these didn't work, because these are passive filters. So they've got continuity from top to bottom. The only thing we can test is continuity from left to right, because these are passive filters, like I say, and the console would work whether or not we left them components intact. So we can check to make sure that we don't have any shorts to ground, and we can check to make sure that we don't have any shorts from one pin to the other, but that's pretty much all we can do with these. This is a lot different design to the PS4, where the PS4 uses active filters, or what I believe are called active filters, where they're actively part of the circuit and they're actively doing something for the circuit, whereas these are what I call passive filters, because it would work without them, and they are still filtering out electromagnetic interference, but it's doing it passively. And if these burn out, then the console would still work. You might get a bit of data corruption, but it would still work. So there's no shorts from one pin to the other. Let's check for shorts to ground. And they're all good. So no shorts to ground, no short from one to the other. So let's move on to this IC here. So this is the TDP158. It's a Texas Instruments HDMI encoder, 4K encoder IC. And this chip is responsible for taking the audio and video signals, synchronizing them, and then passing them through to the HDMI circuit. So this is basically a video encoder. And we can check a few things on here. We can check for shorts to ground on the capacitors and the resistors, and that's pretty much it. And if those pass, then we're going to replace the chip anyway. So we can just check them just to get confirmation on whether or not it could be bad. But even if these check out fine, then there's a good chance that the chip is still bad anyway, because everything else checks out okay. One of these is meant to be shorted across the ground. I believe it's that one. I just realised you couldn't actually see. I'll just show you these again. This one is meant to be shorted to ground, and that one's good. Okay, so all of the components test okay, but I'm gonna put my money on the fact that it's probably the chip anyway, because it's the weakest link in the chain. So I'm gonna get this chip removed and I'll replace it with a brand new one, and then we'll see if we get a display. So right now I've got my hot air set to 480 degrees and I've got my airflow set to 60%. And this is going to take quite a while to remove, so don't rush this. These boards are very thick and the ground plane sucks up a lot of heat off this chip. And that chip's removed. So now what I want to do is prepare the pads for a new chip, because I don't want to use that kind of heat for very long on a new chip. So what I'll do is just replace the solder that's on these pads with fresh leaded solder, and I'll start that by wicking away the old solder using some soldering wick and some flux. So let's add some flux there. And let's replace the solder that's on here now. That's going to reduce the temperature and allow us to remove the solder a lot easier. And then I'm just going to wick away and clean up all of these pads. There we go. So now we just need to clean up this flux, and then we can pop some fresh solder onto the pads, and then we'll be ready to install a new chip. Okay, so let's add some fresh flux now. And we'll use enough flux to make Louis Rossmann proud. By the way, if you don't know who Louis Rossmann is, you should absolutely search for him on YouTube. He's a fantastic technician. He works primarily on MacBooks, but he has certainly taught me a lot over the years. Okay, so I'm just going to replace the solder on these pads. And let's add a little dab in the middle. Perfect. Okay, and now we're ready for a new chip. So I'm going to grab a brand new HDMI Retimer IC. You can buy these from DigiKey and several other websites. They're not too expensive. If you buy them from eBay, they're going to cost you a little bit more, but they're not very expensive, so it's not an expensive job to actually do. So the part number for these is TDP158. It's a 4K HDMI Retimer chip, or redriver chip as most people call it. Okay, and I'm just going to flow this into place with hot air. I'm going to move the chip out of the way for a minute. Okay, now I'm going to put some more flux on, and I'm going to press down on the chip and squeeze out the excess solder from underneath the chip. There is going to be some excess solder on that centre pad. We want this as flat to the board as we possibly can to make sure that every joint gets a good connection So we'll press down on the chip with a pair of tweezers. And you can see that went down flat. And now we're going to clean up using the soldering iron. We'll add more flux. And then we're just going to run the iron across all of these pins. Just make sure we have a nice strong connection on each one. And here comes the awkward part for me, the one on the right hand side. I'm a left-handed person. Okay, so now I'm going to give it one last reflow using hot air, just to make sure that it's in position. And it certainly appears to be. Didn't move out the way or anything. And that's it, job done. So I'm just going to clean up now. So I'll use some isopropyl alcohol and a flux brush. I'm just going to wash away the flux from the area. We don't want to leave any flux there if we can help it. And finally, I'm just going to dry the area with some more hot air. Beautiful. Okay, so what I want to do now finally is just inspect this on an angle, make sure that every single joint is soldered correctly. And those joints look absolutely beautiful. Same with that side. Nice smooth joints. Flip the board around and we'll inspect the other ones. Okay, so I'm going to touch up these ones here on the top. They're not quite as good as the rest of them. So I'll just use a bit of flux in the soldering iron. Okay. So let's just clean up once more then. Okay, let's dry up. And that is more than acceptable. Right, so as we can see there, we've got a brand new chip installed. So what I'm going to do is I'm going to clean the thermal paste off the APU and off the heatsink, and then I'll get it back together enough for testing and make sure that it works. Okay, that is more than good enough. Let's get some fresh thermal paste on there. And what I'll do with the Xbox One X's and the PS4 Pro is I'll spread the thermal paste manually, just because the APU itself is a lot wider than a normal APU. So by spreading it manually, it ensures that we've got a sufficient amount of paste nice and evenly spread across the APU. There we go. Okay, and I'm going to give this a clean, make sure there's no dust left inside there, and then I can start screwing everything back down. I may as well put it all back together now, because I'm fairly confident that changing the retimer is going to solve the issue. Okay, so one thing we tend to have to do with these is put the power supply screws in first, just to hold it in position before you put the actual power supply in, and also the same with the hard drive as well. Otherwise it just falls out and you end up fighting for ages with it just trying to get it back in. So I always do this first, just makes it easier to reassemble, and just pop one screw in there, and that just makes life a lot easier. Same with the hard drive. We can pop a screw in, just enough to hold it into place. So I'll hold it in position, and I actually pop two screws in this, one in one corner and one in the opposite corner. Okay, and now I can carry on reassembling. Okay, and that, ladies and gents, should be working. So I've been recording now for 57 minutes and 48 seconds, and that's all it's taken me to do this job, whilst recording, whilst explaining everything what I'm doing, and also to reassemble it as well. This is a job that without recording shouldn't take more than about an hour. Let's just hope it works and I don't make myself look like a bit of a fool, but it should be absolutely fine. There shouldn't be anything wrong with this now. So what I'm going to do, I'm going to switch over to my camera in a second. Right, so desktop view there. I'm going to plug the HDMI cable in now. Here we go. And there we go. Xbox One logo. Perfect. Absolutely perfect. Less than 1 hour with recording and faffing around with the microscope and explaining what I'm doing, and this console appears to be working absolutely fine. So without recording, this is a job that shouldn't take more than about 40-50 minutes for an inexperienced person, maybe an hour for if you're inexperienced. Right, it looks like someone has decided to try and press the sync button with the power button. Please don't do that, because it makes my job a million times harder. Never mind. Right, so let's just test all of the different functions then. So we've got controller sync, and I'm going to run through setup now. Right, okay, so ready to sign into a Microsoft account now. So I'll sign into my own, and then I'll delete it once I'm ready to put it back into the package, ready to ship back out. Okay, and now we're ready to run a couple of tests. So we already know we already know that it signs in okay, which means that the Wi-Fi card is working absolutely fine. So let's test the disk out. We also know that 1080p works absolutely fine as well. So that's absolutely fine. And FIFA 17, so it's reading a disk as well. So I'm just going to remove my account, and then we're ready to go. Then we're ready to call this one done. And there we go. So this one is pretty much done. Let's just skip signing. And let's cancel the installation of FIFA 17. Cancel that. There we go. Excellent. Okay, so this one is pretty much done then. So let's just summarise then. So this console was originally sent in because it had no display, and by moving down the line from the HDMI port backwards, we've managed to determine that the only thing that it could possibly have been was, of course, that HDMI Retimer IC, and by replacing that, the part number for that is TDP158, but by replacing that, we've managed to restore the HDMI circuit, and this console can live to fight another day. So that's going to be for this video. Thank you very much for watching. If you have any comments or questions, leave them down in the comment section down below. If you want to see more repair videos, be sure to hit that subscribe button and turn on the bell notifications so that you're notified every time that I upload. I am trying really hard to get to 6,000 subscribers by the end of January, so if you could subscribe, it would really help out the channel a lot. I also now have channel members, where my channel members, for as little as £1.99 per month, supports the channel and gives you early access to most of my repair videos. But that's going to be it for this video. Thank you very much for watching, and until next time, see you later. Bye for now.